Okay, third video. Given we went a bit off the camera in the last video, we'll just review this side here. So one of the areas we look at, or one of the groups of substances we look at in terms of chemical equilibrium is acids and bases. Okay, now last year we looked at the Arrhenius theory. This year we will look at the Bronsted-Lowry theory. We will again consider weak versus strong acids and concentrated versus dilute acids. Okay, now just our subject matter, Bronsted-Lowry, you'll be looking at subjects matter 15, 16, 20 and 22 are all related. And in weak versus strong and concentrated versus dilute, 24 and 26. From this information here, we have a look at the pH scale, and we use our rule pH is equal to minus log H plus, but there are approximately 8 or 9 rules that are related in subject matter 18 or 19, but they all basically derive from this one. Now we can write, using our equilibrium law, we can write an equilibrium constant for water, and that equilibrium constant for water is called Kw. Okay, and that's subject matter 17. From Kw, we can then come up with equilibrium constant for acids, so Ka, and one for Kb. Okay, so it's bases. So it's subject matter 25 and 27 there. Okay, now water, it turns out, is amphiprotic. Okay, and with that, that's subject matter 21, we get this idea of conjugation, which relates back to Bronsted-Lowry. From conjugation, we then get buffers, and then we're looking at subject matter 23 then. Okay, I think that's all for that section there. Okay, continuing on with acids and bases. Okay, acids and bases. We will then look at indicators. Now, indicators are weak acids. So they are weak acids. Now that's subject matter 28 we'd be looking at there. From indicators, we will look at this concept called pKa, which relates right down the bottom here to Ka. Okay. pKa, we will then use pKa, or probably more likely we'll start with titrations and work back to pKa. Now with our titrations, we've got two important points. We've got the end point and we've got the equivalence point. Okay, so we are looking at, that will be subject matter 30, 31 and 32 it looks like. Okay, from our titration, I should add here endpoint relates to the indicator colour change. So that's the colour change of the indicator, while the equivalence point is when H plus concentration equals OH minus concentration. Now from those titrations, we'll create graphs. Okay, and those graphs, just let me check, so that will be SM33 we're looking at there. We will determine concentrations of acids and bases. Okay, and they'll be looking at SM34. Yeah, I think we've got almost everything there. No, not quite. From our graphs, we will look at this point where pH is equal to pKa, and that point is known as the half equivalence point. Okay, Now I think that's about all. I'm pretty sure that half equivalence point. Just let me change screens here and we'll find what subject matter, but I'm pretty sure it's 33. Yep, it's 33. So this use of this graph and this half equivalence point all comes under subject matter 33. Okay, well that's it. That's what we've got to basically know. Out of all of that, you have a mandatory prac that is based on a titration. Okay, and of course that will form one of your options for your student experiment. Okay, so now that looks like a lot, and yes it is. And we've got around about 4 weeks to cover that in. A lot of it is definitions. The maths is here and up here really, and down here. Okay, so maths down here, maths here, and then maths up here. Okay, oh yeah, thanks for listening.